Okay, we're going to have a look at this inequality problem. Now, if you're not one of my students and not from my school, then this notation may seem a bit strange to you. This means x is such that, or we have x in a situation where we have 1 1/4 is less than x is less than or equal to 4. So basically most people would see this problem on an exam paper in this way, and it would be written as 1 1/4 is less than x is less than or equal to 4, and you just need to know that x is a member of all the real numbers, and we'd want to draw that as a number line. Now remember, when we have this symbol here, the inequality symbol, that one there, then if there's no equals, then we just draw an empty circle to indicate that we don't want to use the value at that point. So 1 1/4, which is about here, okay, we're going to draw an empty circle, and then we know that it's going to be here, this symbol. We're very keen that this is equal to the value 4, so therefore we draw a filled in circle. So we colour in the circle and fill it in at 4. Now we know that x is going to be greater than 1 1/4, so it's on this side, and less than or equal to 4, so it's on this side. So we join up these two circles with a line, and we indicate that this is where, on the number line, that our number can fall, because it's a real number. Now in this problem, we've got the same situation. We're really just dealing with minus 4.5 is less than x is less than 5. But now we've got a situation where x is not a member of the real numbers, it's only a member of the integers. So we need to find a way of indicating that. Well, 4.5, we're not going to include that, so minus 4.5. Right, empty circle, minus 4.5. But we're going to include every integer from there up until we get to 5, which we're not going to include. So we're going to include this value, this value, this value, and so on. Keep shading them all in, all the way, and we won't include 5. And there's two ways we can really show this. We could just actually just fill in the ones we want, but actually it might be nice. That was a limit. It was less than 5. So if we just leave that with an empty circle, and this with an empty circle, although it's better probably written, we've just filled in dots between minus 4 and 4. I've just put those in to indicate that we're not interested in those, and they're the boundary values that were given to us in our question. So that is our answer for this question. Now we're going to move on to look at the reverse questions. So we're going to look at how we could write these questions out. We're using our notation before, that's special to my school. You've got x is such that. Now here we've got x not equal to 2, but it's going to be bigger than it. So therefore we're going to write the value 2. We don't want it to be equal to it, but we want to be bigger than it. So no equal sign. X. And we want it to be less than or equal to 4. We're going to include the 4 because that's filled in. But we need, now because it's a continuous line, x must be a member of the reals for that to happen. Okay, real numbers. Remember, all real numbers are all numbers that can be drawn on the number line. Let's just look at this one here now. On this one, all we've done on the number line is indicated 4, 5, 6, 7 and 8, and no other values in between. So here we're going to have x is such that 4 is going to be our lowest value. Now we can be less than or equal to it because we have got it filled in, and we're going to go x all the way up to 8, and I'm going to use the less than or equal to sign. Comma. Now x could be a member of the natural numbers, okay, our counting numbers, okay, not drawn that very well, or x could be a member of our integers. Alright, either of those two answers will be okay. Alright, because in both cases we're talking about whole numbers between 4 and 8, and both of those give whole numbers between 4 and 8. Now I'm just going to move down to this question here. Can you solve the following inequality and represent it on the number line? Well, we've got the inequality 2x minus 4 is less than or 18. Now we just treat inequalities just like equations, except when you times or divide by a negative number, you need to remember to flip this symbol here. Okay, very important, you flip this symbol here, because timesing the whole number line by a negative number means that all the numbers on this side become negative, all the numbers on this side become positive. So effectively you're flipping the number line over. So you must remember to flip your sign when you times or divide by a negative number. So in this case, what's the first thing we do? We're going to get rid of this minus 4, so we get 2x, add 4 to that side, we get 2x, add 4 to this side, we get 22. Now divide by 2. Well, we're only dividing by a positive number, so no need to flip the sign. So we get 22 divided by 2, and we get x is less than 11. Now notice it's a member of the integers, so if we're going to draw this on our number line, we're not going to include 11. Okay, we're going to just include the numbers from 11 downwards. Sorry, I've made a mistake. Can you spot the mistake? I said I wasn't going to include 11. So I'm just going to get my rubber, get my small eraser, and maybe we can just rub some of this out. There we go. I'm just going to draw it back in again, fill the line in. Yeah, we didn't want to include 11. In fact, you could get away with putting an empty circle at 11 to indicate that was our boundary value that we were dealing with. So this is all the numbers less than 11, and we're going to continue going this way, so forever. Right, there is no lower bound, we just got an upper bound.